Connective tissue is going to be another tissue type, and this one is going to be the most diverse within the body. Also is going to be the most abundant and also widely distributed. It has a lot of different structural variations to it compared to the other tissue types. And so the connective tissue, to think about it, is going to connect the organs together. All right, so it acts as like a glue and filler of the body. And so examples are going to be tendons, ligaments, fat, bones, cartilage, blood, and lymph. All right, so there's three different things that we need to keep in mind when we talk about connective tissue. So the first are going to be the cells. The cells are going to be different and depends on where it's found within the body. So some examples are like fibroblasts, which make up the collagen fibers, protein fibers. Also we have osteocytes, for example. These are going to help make up the bone, and then adipose sites, which are going to make up fat. The second thing that we have are the protein fibers. The three ones that make up the connective tissue are elastic fibers. These are going to be the most flexible and also the smallest. So here's an example in this image. Here are our elastic fibers. Also, we have collagen fibers, and so these are going to be a lot larger and most diverse within the body, and these are going to be the red here that we see, and helps to give that strength and support for connective tissue. Also, what we have are reticular fibers, and so these are going to be intermediate in size, helps to act as like a meshwork for the rest of the organs. All right, and then lastly, what we have is ground substance. And so ground substance, like what I'm circling here, this is going to be non-cellular material. So mostly it's going to be made up of proteins and carbohydrates with different salts and minerals and water. And the protein fibers and then the ground substance, so ground substance and protein fibers here are going to make the extracellular matrix. Extracellular means outside of the cell. All right, so the functions for connective tissue include physical protection, and again, this is going to help be that glue and that filler portion, and so bones and cartilage are going to add in for that protection. Also, we'll have support and structural framework, so this is where we'll have like adipose tissue is going to come in and reticular tissue, and this will help in order for the body to hold its organs in place. Also, binding of structures together so that they, like for example, ligaments are going to help bind together bone to bone. Tendons are going to be muscle to bone. Storage, so within our bones, again, for example, here we're going to store different ions and minerals such as calcium, phosphorus, so that we can use this later as a reservoir. Then we have transport, and so this will be for the fluid connective tissue, so blood and lymph will aid in transporting our different materials, and also what we have is immune protection, and this too will be with our fluid connective tissue of blood and lymph. So the types of connective tissue after birth are classified into three broad categories. So the first is going to be the connective tissue proper. Then we have supporting connective tissue and fluid connective tissue. So the connective tissue proper is going to be divided into two more groups. So we have the loose connective tissue and dense connective tissue, where then we'll have three other variations from that. So we'll get to that in a little bit. The supporting connective tissue, this is going to be cartilage and bone. And so cartilage, we have three different types of cartilage, and then we'll have two different types of bone. And then fluid connective tissue will include blood, and also I'm writing in here, lymph. So when we look at connective tissue proper, there's two main things that we need to consider. The first one is going to be the group of cells that compose it, and the second are going to be the fibers. So when we talk about the groups of cells, we have resident cells and wandering cells. Resident cells means that it's going to stay in place. They're going to be fixed in a location. Wandering cells means that they are going to be circulating and milling about and scavenging throughout the body, looking for different things in order to help. So examples of resident cells include fibroblasts, adipose sites, fixed macrophages, and mesenchymal cells. Whereas wandering cells include mast cells, plasma cells, free macrophages, and different leukocytes. So again, resident stay in place, wandering, they're circulating about. All right, the second thing with connective tissue proper are going to be the different types of protein fibers that we see. So the first is going to be collagen, which is going to be the most abundant one in the body. And so this helps to make about 25% of all protein in the body. And the second one is going to be the elastic fibers. And so these will be much thinner than collagen, and they're going to stretch easily. And they're going to branch and rejoin. These fibers we find like within blood vessels that are able to stretch and relax. All right, and then lastly, we have the reticular fibers. So these are going to be even thinner than collagen fibers, also are going to form a branch, and these are going to form a meshwork. And so kind of think of like a hashtag sign is going to be the appearance of them. And so we'll find this like in the liver, the lymph nodes, and the spleen. Also with connective tissue proper, what we have is ground substance. So this will be, again, the combination of proteins and carbohydrates that we find within the connective tissue. Now, this is non-cellular material. So when we look at it, it has like this gelatinous appearance to it. So it's going to be like the filler part that we see. And additional content, so we'll find like water and salts here can vary in texture. So it can go from semi-fluid with adipose or hard to bone, where with bone we're going to have more minerals that we find within it, so it has that hard appearance to it. And so let's go through those different types of connective tissue. So first we're going to start with the three main types of loose connective tissue, and then we'll go into dense. So again, the loose connective tissue is going to serve as the body's packing material, so we're going to find this in spaces around organs. The first one here, this areolar connective tissue, is going to contain different fibroblasts, collagen, and elastic fibers. And when we look at this here, it's going to have this airy look to it. So we see a lot of spaces. So what we hear or see here in the light pink and the white. And again, we're going to have all of the different protein fibers that we have. And what we have in this example, so this is a papillary layer of the dermis. So this is what we find underneath the skin, the outermost layer of the skin. So it's going to, again, help with the cushioning and packing of our organs. Adipose connective tissue, another example of loose connective tissue, adipose known as fat. And so the cells that make this up are going to be adipose sites. And so when we look at the adipose tissue here, we see adipose sites. And they're going to have these large globules that we find, and then these are going to be large and prominent when we have them like underneath the skin layer. So the subcutaneous layer is where we would find this, for example. The last of the loose connective tissue is going to be this reticular connective tissue. So this has reticular fibers are going to be predominant. We'll have fibroblasts and also leukocytes. And so we find this, like, for example, within the spleen. And when we look at the appearance to it, kind of has like this hashtag sign all throughout. And that's going to be a difference that you can tell the reticular fibers from the elastic fibers. Elastic fibers are going to be pretty uniform and span the length of the organ, whereas here it's going to be intertwined so that we can have different like blood cells entering and exiting within the spleen. The next category are going to be dense connective tissue and the second portion of the connective tissue proper. So now the difference here is that it has strong fibers that are mostly going to be composed of collagen, and they're going to be tightly packed together. So we're going to have little ground substance. And so the first one we'll talk about here is dense regular connective tissue. Regular because it has a regular appearance to it, and dense because the fibers are close together. So here we have collagen is going to be parallel to one another, and so this is an example of a tendon. Now the appearance though here we have is going to be like this wavy appearance, and then we'll have these dark purple are going to be the cells that we find within them. Second type of dense tissue is going to be dense irregular connective tissue. And so again, collagen is going to predominate. However, it's going to have this irregular appearance to it. So unlike the dense regular, I'm sure you can see already, we have all directions of these collagen fibers. So for example, reticular layer, so this is going to aid and support and can be pulled in multiple directions then. Lastly, of the connective tissue proper, we have the elastic. And so elastic fibers here now are going to predominate. And so this is going to aid in stretching and recoiling. So what we have here then are going to be like the aorta, where it's constantly undergoing the constant change when we have high amounts of blood pumping versus then no blood pumping through it. And so this too has a low amount of ground substance, which in this figure we're looking at that white. And then these elastic fibers are going to be thin thinner than collagen and are going to be more in this like wavy shape to it. Now let's look at the two types of supporting connective tissue. So we have cartilage and bone. With cartilage and bone, these are going to make a firm gel-like extracellular matrix that's again composed of protein and ground substance. For cartilage, the cells are going to be chondrocytes. And so they're going to occupy small spaces that are enclosed with their extracellular matrix. And these are important because they will support and withstand different deformations. And so hyaline cartilage, the first type of cartilage, is going to be the most common, but it's also the weakest. And here, when we look at it, it has this beautiful appearance to it, and it looks almost like glass when we look at the microscope. So example, this is going to be the articulating cartilage on bone. Next, what we have is fibrocartilage. This is going to be the densest of the cartilage and so the strongest. And these have like interwoven fibers, and here we have this regular appearance to it, right? So this is some areas we find this in would be like intervertebral disc, so in between our vertebrae. Also what we find within like the menisci of our knee. Lastly, we have elastic cartilage, and the predominant fiber here is going to be elastic fibers, and so allowing for flexibility. So our ear will be an example of this elastic cartilage, and here what we can see, these little strands, these are going to be those elastic fibers. All right, so bones now, the cells for bones are going to be osteocytes, and the extracellular matrix now will have a mixture of both collagen and now calcium salts. And so this is going to be that storage reservoir of calcium for our body. And this mixture helps with flexibility of the organic components and then gives us lots of strength from the inorganic components of these minerals. And what we have are these arrangements that look like little bullseyes. And so these are going to be the osteons, which are going to be the functional unit of the bone. Now, going into fluid connective tissue, this most commonly is referred to as blood, but also lymph serves its purpose as well. And so there's different components of plasma where we have the water ground substance that are going to be the protein fibers. So if you get a blood draw and you spin it down, the lighter portion, the yellow, is going to be our plasma. The erythrocytes are going to be the red blood cells that we see. And the leukocytes are going to be the white blood cells, fewer in number but larger than the red blood cells. And then lastly, what we'll have are different platelets, and these are fragments of bone cells that are important for blood clotting.